Hello there. Welcome to this Shieldia guide for the damn vulnerable web application brute force on medium security. Today I'll be discussing how we can utilize ffuf to brute force the damn vulnerable web app. I'll also be providing some obfuscations so that if you're using the detection infrastructure from the low security guides, we will successfully subvert that. If you followed along in the reconnaissance phase of the medium security and installed mod security on the Ubuntu guest, that you don't need to disable it. I'll be providing bypasses such that we'll be able to enumerate all of the usernames to bypass the WAF rule and actually be able to brute force the brute force challenge. Without further ado, let's jump right in. As always, you're going to need the prerequisites if you want to follow along at home. If you don't have your own Kali or damn vulnerable web application instance, you can follow the red team setup. If you also want to bring up the SIEM, you can follow the blue team setup. Again, if you have mod security, you can leave it on for the remainder of the red team perspective. First, what we're going to want to do is attempt to just log in with a basic browser to see what defenses may or may not have been put in place by Mr. Programmer. Again, on the Kali guest, we can find the damn vulnerable web app by the custom domain name. We can log in, set the security to the appropriate level, and then finally brute force. If we try to log in now with an account that does exist, and then we're going to try a fake password. Let's see what happens. Okay, you can see there it took a little bit of time to respond. If we instead looked under the network tab, we can see, okay, that responds pretty quickly. But no, there's a 2-second delay. So, and if we try that again with a fake password, don't update, you can see here it's delaying us by about 2 seconds every time we want to make a request. That means that in the background, it's just probably implementing a sleep function. So what does that actually mean? It's just going to slow us down. We could still brute force it if we're able to correctly insert what we need. However, it's just slowing us down. No other issues there. As you can see here, the 2-second delay, it's not going to stop us. The first and primary tool we're going to be using today is ffuf. We're not going to be covering how to do this in Hydra because I've already covered that in the low security, and ffuf is a bit more programmatical for these sort of web application testing. We're not going to be obviously using it to log into an SSH account or something like that. However, for web-based stuff, it works perfectly fine. First, you're going to want to make sure you've unpacked the RockU word list on the Kali guest. Next, we're going to try and get the username list like we did for low security. However, you'll be posed with an issue if you attempt this. Our curl, and then we give it, so silent, we give it the directory that we want to enumerate, and then we can pull all of via grep regex for all the JPEG images, but we just want to capture group that word so that it's all of the usernames, and then we put it into the damn vulnerable web application users file. If we do that and we cat that file, users, there's nothing in it. The reason is that with mod security is blocking the response body because it has index of in the response body. Mod security will just block that by default because in normal applications, that's probably a security issue somewhere. However, we can still get the list of users that we need to enumerate. It just takes a little bit longer. You can see here by way of demonstration, this is the particular rule that's being hit within mod security. So we want to subvert that if we can. To be able to do that, this is the incantation. I'm going to clear that, minimize that. And then you can see here, ffuf, E for extension, anything that's a .jpeg, because you know images are served here. If you log into a user, then you see their little image. It's a .jpeg, so you can assume that'll end in .jpeg. The specific URL that you want to fuzz, the fuzz keyword, then we're modifying our user agent. So even if the user agent was in the previous command modified to be something that's not going to be detected by mod security, it's still hitting that other rule. So there's two rules that it could be hitting and it will be blocked either way. Here, we're just giving it a custom user agent. Again, the same caveats from the reconnaissance apply here. These things do eventually age out. And if you're a network admin and you're seeing get requests from a user agent that's like 5 or 10 years old, that's very suspicious. Then we're going to do a match code for 200 follow redirects and then giving it a specific word list. It's this XantoNet 10 million usernames.txt. We're not going to go through all 10 million at the moment. However, if we run that, and as well, you'll notice we don't need the PHP session ID for this because these pages aren't actually protected. Anyone can access them. You can see here that user list starting to be generated because it's able to successfully get these images from the server for admin, for Pablo, for Smithy, and then we can use them to create the word list later on. It's going to cancel that because we already know what the word list is going to be. So we can copy this and then create it into the user list. Down on the web app, users.txt, insert mode, paste, exit, by. Cool, that's done. So now we have all of the users. Now moving on to how do we actually use that to brute force. Now we're going to need the PHP session ID because these pages are actually protected. Again, this fills in, it's a variable substitution in a sense. So PHP session ID will become whatever the result of this command is. This subshell will execute first and then assign that variable to PHP session ID within this shell instance. What this does is gets the cookies database in the Netscape format. We are getting the user token. We then do an xargs from the cookies database to log in, to do a post request, login, and then the data we are sending is username, admin, password. The user token is what we've xarged and then log in. Then we want to grep a particular value from that result, and that value is our PHP session ID. That's a valid PHP session ID that can actually log in. Once we run that, we can then echo PHP session ID. And there we go. We have a valid PHP session ID that we can then use to log in from the terminal. We don't need to do this login via the GUI. Blah, blah. Now, utilizing ffuf useful, we can provide it with the particular URL that we are targeting, down vulnerable web application slash vulnerabilities brute, and then the username is a user, which we are providing with a word list, and password is pass, which we're again providing with the user with a word list. Login equals login. Match response, welcome to the password protected area, follow redirects. The data, in a sense, that's going to allow us to do these requests is going, the cookies, in a sense, is going to contain security equals medium. This has changed from last time where security was low. And then the PHP session ID, and again, we just provide it with that variable, and then it will fill in this particular variable there, and then that will be a valid PHP session ID. We're also going to modify the user agent, so it's not the default ffuf full user agent because that will be blocked by the WAF. And then we're providing it with the user list and the password word list. Finally, you have to specify the threads. In this instance, threads has to be way under 40, which is the default, because if you start 40 threads, all of a sudden, it just DOSes the application and then it becomes unresponsive to all future requests, and then you have to restart the Apache process. It's no fun. So instead, just bring the threads all the way down to 5. It's going to take longer, but it is actually going to work. And then you're going to want to get a time, you're going to want to stipulate a timeout for the actual requests. In this instance, it's 15 seconds. That's the request timeout. That's not the total time before it actually gets a response. Now we can run that command and it'll go through 5 requests at a time, slowly building up until it finds a response with that particular phrase in it. We can see within the blog post that would work. As you can see here, eventually it'll find responses with those codes. We're not going to worry about that too much now. I'm not going to just run and do that. Oh, you can see here, we have actually tripped a rule. It's a rule that's enabled in my custom rules. Because the response speed has suddenly increased, it's starting to get 403s. It's a rule that will just have to be disabled when you run these tests. It's a custom rule that'll just need to be disabled when you run these tests. It's easy enough to disable. We can go through within the terminal, which will be over here. Clear the screen. Vagrant SSH download web app, and then just disable that rule. Which we'd want to disable all of the custom rules for now. Simple enough. Sudo vim clear screen etc mod security conf. No, it's the other one. Sudo vim etc apache mods enabled security2.conf. And then in here, we're just going to comment this line out to remove our custom rules. Sudo, probably in the command history is a start. That'll just restart that. Awesome. Let's restart without any errors. We can try this again, and then it should not increase to catch that other particular rule that will be discussed later on. All is looking well so far. So that's just one of the ways that you can bypass the default mod security rule sets, is that, for stuff like this, because they have to be generalists in the way that they do stuff, so it can't be as specific as you'd want it to be if it was within your own enterprise or if it was something that you were targeting. So you can see, yes, there is actual successful responses, and it's still going as slowly as it was before. So it indicates that we haven't tripped any of the rules. Great. We can cancel that. You could let it go or continue at your own leisure. However, for now, we don't need to worry about it. So now we've successfully been able to brute force bypassing the WAF, and it's something useful for your own engagements. It will work. Fuzzfast default is great for this sort of thing. If, however, you didn't want to use Fuzzfast default, Hydra is also fine, and the other frameworks, you wanted to do it in Burp Suite, you can, but there are limitations in the number of requests you can send per second, but let's not worry about that at the moment. Instead, moving on to the side channel, HTTP method abuse. I was looking for other ways that we could subvert the detection logic, because at the moment, these would all still be detected within the seam. So if you wanted to subvert that, there are some other ways we could do it. The first method is the head method, but the success or failure criterion that we're looking at the moment is actually contained within the message response body. So we can't use head-based obfuscation. Another method I investigated is sending parameters within a GET request body itself, as in the data. You could, for some applications, namely Elastic, this works for some endpoints, that you could use a GET like a POST request. It doesn't work in this instance. Okay, no worries. But crucially, we can actually send what we can abuse POST to act like a GET request. I'll demonstrate that now quickly. Moving to our machine, our Kali instance machine. Again, we're populating the PHP session ID variable with a new PHP session, just to make sure that it's populated with the most up-to-date, because sometimes it can expire. Then this incantation, fuzzfastUFull, we're providing an X method, which is the way that you tell a lot of these command line tools what method to use, default being post, but you could do the default being get, but you could do post, put, options, head, all of the other ones. I'm not going to worry about that too much. And then the rest that would look familiar to you from the previous time we ran fuzzfastUFull. However, it's just using a different method. So if we were to run this, what happens? It acts like a GET request. The application treats it as if it's coming from a GET request, even though it's coming from the post method. Very interesting. So what that means is all of the detection infrastructure that was written by the blue team will be circumvented because they all presuppose that get is the only method to be able to successfully log in to this application. Just something to think about. Again, we should be seeing successful responses. There we go. We can see successful responses. Great. Moving on, there is also a nuclei template. I understand it's more purple team stuff, but there is a nuclei template that does just this to be able to test and validate these things. Finally, this is the code that it's using, from my understanding, for username and password. Your if is set get, as in get request login. So if that variable is set, but it's not strictly matching for just get, it will also match for post, which is quite interesting. So that's just some ways we can circumvent or obfuscate our activity when you're dealing with these endpoints. Have a look. What other methods does it actually respond to? Is it only get? Will it respond to post? Will it respond to put? Would it respond to options? Would it respond to head? All of that are things to keep in mind when testing this infrastructure. It could just be that Mr. Programmer didn't quite fully comprehend all of the different ways that the application may or may not respond. Hope you've enjoyed this part of this episode. I will see you in a little bit for the blue team section, where we will be providing all of the defenses against the dark arts, against the red team. And now for the blue team part of this guide, where I'll be providing elastic rules, updated rules to be able to identify the obfuscated activity, and then updated mod security, custom mod security rules to be able to prevent that actual activity. So in this video, I'll just be re-enabling the custom rules that were disabled in the previous part. The first thing we're going to want to look at is to be able to actually detect the obfuscated, because that's more advanced adversaries will endeavor to obfuscate some of the activities they would be undertaking against your infrastructure. We want to be able to detect that. Firstly, the initial reconnaissance to be able to get the username list leaves a trail. It leaves a very clear trail, which is an increase in the number of 404s per second. If we're to graph out all of the get requests by 404 for your application, you would see a spike at the time something like this would have run. To verify that, we can log into the Elastic Seam if you're running the blue team part of these guides. Go to the Discover tab, always select logs. For some reason, it just kicks me out. Just log back in again. Don't worry about it. And then, if you want to get rid of the security certificate warnings, just import the certificate into your browser trust store, and then that'll be all good. Then we're going to look for http.response status code. Boom, we look for that, and then we're going to look for 404. Over the last 30 minutes, boom, you can see a huge spike at 11:57 for 404 response codes. Obviously, within an application, there would be like a nominal amount of 404s that would be received throughout the day. Then you're going to want to look for maybe a standard deviation away from that normal response code. If you were perhaps being targeted by if they're using multiple proxy chains, source IP addresses is what I'm trying to say here. That's one way you could look at it. The other way you could look at it is on a per source IP address basis. That's what the rule in this instance endeavors to do, is instead it will just look at it via each individual source IP address and then look for an increase in the volume of 404 response codes for a certain period of time. If we were to look, for instance, if you look under the alerts section, you will see some of the activity that we undertook within the red team part of the guide. In this instance, we're looking for Web Apache correlation direction generation medium security, like this. We can look at the definition for that particular rule here, where HTTP response code by a single source IP address, the source IP address and host name, is above or equal to 1,000 in a 5-minute window. they'll indicate that there is some directory enumeration. It's low because you don't really want to just ban them, stop them, boom, done, gone. It's just, again, stuff further to the left of the MITRE attack framework or closer to the reconnaissance phase in cyber kill chain will necessitate less harsh responses. You could put this into a SOAR and then just block that source IP address. However, what are you really stopping when you do that? You're just slowing down this type of enumeration. You could do that. It'd be perfectly valid. But just note, it's not a be-all, end-all. It's not going to solve all of the problems. Moving on, we can, here we're verifying that those, for the brute force, we can verify that that also works. Looking in the seam, we can see here web Apache correlation brute force, and then the Apache correlation brute force medium security is what we actually want to look at today. This then also removes the get part of the request, and web value counts 20 failed login attempts over a 1 minute time window, because that's pretty suspicious. If you're getting 20 failed logins in a minute, you either have a really short password or be a really quick typer to be able to get that. Moving on, what about the post-based obfuscation? That's just what I demonstrated there, is that in the initial logs, it wouldn't actually come up in the seam, as you can see here. Why is that? Because the original alert looked for get and get only based requests. However, within the Apache logs, this is what it would actually look like. You could see post and then the specific URI. Again, all in quotes because it's unsafe, so we don't need to worry about that. But you could see here as to how it would look to the Apache access log. And then we're going to want to, if you look at this rule definition, just change the request method, remove get, and jobs are good, and Bob's your uncle. Moving on to mod security. As it says here, an ounce of prevention is worth a pound of cure. If you have the capability to prevent something in the first place, that's what you're going to want to do. In this instance, we're going to be preventing a few different avenues that the adversaries have used to obfuscate our traditional seam-based detection. First is we're going to block the get-based brute force with a particular custom targeted focused rule. If the request URI begins with vulnerabilities brute, we're going to want to, and the response body username password incorrect, that will tell us that they are failed login attempts to the particular brute force directory. This could obviously be somewhere else within your infrastructure, or it could just be if the parameters contain the word login or something like that. You can make it a bit more generic. However, the more generic you make these rules, the more false positives you might be introducing into the system. So that's just something to keep in mind, that you're going to want to find a balance that's appropriate to your organization. We're going to want to look at if the source IP variable that we set here, set var IP. So if IP fail get login counter, again, this failed login get counter here is greater than 10. So this counter increments every time this log fires. Again, there's a bug and some stuff that doesn't increment, but we're not going to worry about that at the moment. If it increments to anything above 10, just block it. Just deny them. So that's what we saw previously, where I had to quickly disable these custom rules, is that once that increments above 10, it'll start blocking, and the blocking action would result in a 403. So ffuf base rate, because of the way that the medium security is constraining the logins to happen every 2 seconds, that base rate increases to something that's like closer to what you'd normally expect ffuf to be. That indicates that blocking has in fact taken effect. That's a lot of things to say. To say this, we could demonstrate it now quickly with, again, populating the PHP session ID and then the ffuf timeout. This, again, with the correct word list that we would have populated earlier. We'll go through. Okay, you can see the slower requests per second. Now we're populating that variable. Actually, wait. We need to enable it first. Going into the damn vulnerable web application Ubuntu guest that you ran Vagrant up from, we can quickly enable it because at the moment it's disabled. Once it's enabled, we want to then do a little restart. It's that way, restart the Apache process to make sure everything's working. Now it will use the custom rules that we've just created to be able to block this traffic. We will clear the screen and then run this command again. You'll see now it's slowly incrementing that counter until it gets above 10. Then you'll see this request rate rapidly increase. So we're just going to let that counter fill up. Once it's full, you should see. Boom. There it is. Now we're at like 200 requests a second, whereas before we were 0 requests a second. So you can see that the blocking has in fact taken effect. We can cancel that and then go back to our guide here. Just to verify and validate that, you could also look in Wireshark at the response codes. You can see here the particular response codes being 403 for our requests, 403 forbidden, meaning the requests are in fact being blocked. Excellent. The next rule that we're going to want to create is blocking empty post requests to what should be a get-based login. There are some caveats here. The reason why it's just empty post requests is because on Impossible Security, this actually uses post, which it should in real life anyway. It uses post requests to this endpoint. So you don't want to block all post requests. You just want to block post requests that are suspicious, because if it is in fact implementing the post method, then it would have a request body and it should be able to understand that. If the request body is empty, just block it. So that's what this rule will do. Security request method post. Then we want to chain it to begin with the vulnerabilities, so we can reverse the order of operations from last time. Chain it together with that, and then if the request body length equals 0, it's an empty body. Drop it. Goodbye. We shouldn't be seeing any of those requests within our environment because it's just illegitimate. If we then go back to our Kali guest, we can then demonstrate that it would work. The request rate will be a lot faster now, and they'll only be responding with 403s. Excellent. To be able to validate that within the seam, you could look under the particular area within the Discover tab, or you can look in Wireshark as well, and then you'll see the 403 response codes for that. If you want to look in the seam, you go to the burger menu, Discover, Logs, thank you metrics, but logs is what we're interested in. Under logs, you'll be able to see the event.dataset mod security auth log. There we go. You can see a drastic increase in the number of auth logs. And if you want to filter it down, we don't care about these in particular, because this is just the health service check thing that the Elastic agent does, but it does get blocked by mod. We just filter that out. And then we can see that drastic increase. Unfortunately, it's within 403 get IP address, line 24, potential brute force critical. Awesome. So we are successfully blocking these things. So reporting it up to the seam. An analyst can then investigate. Jobs are good. So now you can see how you can use these different tools to be able to work together so you can successfully identify these attacks. If you just have access to the logging from these particular endpoints, which I hope you do, then moving further, you can actually prevent these things from happening in the first place on the network. So you don't actually have to re-architect the entire application. Applying these fixes, of course, fixing the application would be best. But if you are unable to do that, these are some of the fixes that you could put in place to be able to block this type of activity. Hopefully that makes sense. You've learned something. I'll see you in the next part of this video. We will be discussing the purple team perspective for all of this. See you there. As alluded to earlier, there are some issues in regards to how the mod security is able to identify and correlate some of these brute force attempts. If you did it with, let's say, ffuf, it's able to successfully be blocked by mod security. However, this nuclei template that I've written to be able to test these brute force attempts actually doesn't get blocked. So there's a bug, basically, is what I'm saying. There's a bug in mod security. I suspect it's related to this bug report on GitHub, that it's not actually able to successfully correlate all of these things together if you're using mod security, because somewhere in the background it's not able to track that it's part of the same session throughout. It's treating each individual request as being part of their own session. Therefore, that particular variable is scoped locally to that session and it doesn't populate through the rest of the sessions. I suspect. I'm not sure. I say all that to say this. You should use different tooling to be able to test these things, because if we just relied on ffuf to full, great, it works. The mod security rules work, happy days, all great. Not quite. In this instance, doing it with nuclei will be able to successfully subvert that and actually be able to log in. As we can see here, looking at the logs from mod security, we can see a lot of the warning error, the warning level logs, but there's none that are critical. That tells me that it's not actually working as it should. Just when you're running these things, writing these things, testing these things, don't just rely on one singular framework. You're going to want to utilize not as many as possible, but as many as practical in this instance, because here I would have never been able to identify that, oh no, it does actually, the rule works for ffuf default, but completely fails for nuclei. Now, will an APT or an adversary be using nuclei? Possibly. We don't know. We don't know their tool sets. We have to assume that they're going to be utilizing whatever tools that are available, either to the public or privately, that they've built in-house or whatever. So we have to assume, we can't just assume that they'll be using off-the-shelf tooling. They probably will be, but that'll be in conjunction with a whole lot of other tooling that we don't need to get to at the moment. Finally, the Omega CLI section for these medium security posts are split into two. First is just the elastic alerts. Those are tested with mod security disabled. To be able to disable mod security, it's a simple process. Just log into the Ubuntu guest that you ran Vagrant up from. I'm already in the guest, but I could exit out and then show you. It's Vagrant SSH damn vulnerable web app. That will then SSH you into that guest. We can clear the screen because we don't care about the message of the day. We just care about stopping mod security. To be able to do this, there's actually probably only one option, which is sudo vim etc mod security.conf sec rule engine. We're going to replace on with off in this instance. We're not going to go like detection only or anything like that. We're just going to turn it off. Then we're going to want to restart the Apache process. Once the Apache process is restarted successfully, now that all the security settings have been turned off, we can run our tests. Simple Python 3 Omega CLI, and then the specific test files that I've written. For this instance, we are able to brute force the medium security. Awesome. We can then do the post-based obfuscation tests. Those successfully get identified. So both of those two new rules for medium security can get tested, and they work correctly as demonstrated here. Then the mod security rules, mod security then has to be re-enabled for these rules to correctly fire. A lot of them, for instance here, the rule does correctly fire, but that's because we're using some of the obfuscation methods, and mod security isn't able to correctly identify and stop these nuclei scans. However, there is another rule, the brute force post method, that is successfully blocked. And then you can see alerts within the seam. They're not actually alerts, they're glorified searches for the mod security activity within the seam. It's able to correctly identify those particular logs that mod security would generate when it blocks the traffic. If it's able to correctly identify that, awesome. We can see here Nuclei doesn't give any feedback because all the nuclei tests failed. And then you can see here on the first attempt to get the alerts, it's able to successfully get these alerts. They don't actually become alerts in the background, as I've stated. It's just a glorified search for that particular log within the seam. And that's all for today's video. Hope you enjoyed. I'll see you in the next one.